In this video, we're going to get from having these Molex connector pins attached to actually being able to plug the e-chassis in. One thing that we haven't done yet is plug the battery wires into their respective Molex pins. So you can see we just made them kind of arbitrarily long, and I just thought it'd be good to kind of show that last little step. So what we're going to do here is first just cut these to the same length as all the other ones. And of course I'm using cutters that are kind of bad. So now they're about the same length. We've already done the splice. So one of these is a positive node and one of these is a negative node. And we're not sure which is which actually. I lost track, but that's okay because we can check it with the continuity tester. So right, one of these is the two negatives coming from the battery packs, and the other is the two positives. So now I have a digital multimeter here. I have it on the continuity mode, so it will beep if I have any continuity. So let's see. Colin, which one of these do you think is positive and which one do you think is negative?
I'm going to say the left is positive.
He thinks that the left is positive.
So it's going to be right then.
No, I think you're right this time. Oh, I should have said it. Okay, so it's not that I'm always right, it's that Colin's always wrong.
Exactly,
That,
so I think so. Whatever I have in my gut, whatever is correct, and just choose
the opposite of that. Okay, perfect.
Yeah,
oh, wait,
exactly.
shoot, which one was it? It was the left one, right?
Left is not left.
No,
right
left is negative.
Yeah,
right is
I chose
positive.
the left one. There you go.
Oh, you're right. I almost.
That one's positive.
Okay, so this one is positive. So yeah, and I'm just going to be double and triple checking everything. I guess what we could have done also is put the Molex connectors, the Molex pins on. This is a little bit long. We could have put the Molex pins on these and then tested the continuity. And actually, we'll probably end up doing that again anyway. So it's like double and triple checking everything.
Cutters are.
Oh, we lost our cutters.
Where'd they go?
I don't know. All right, well, we've got cutters that have mysteriously disappeared, so instead I'm just going to use the slightly less good cutters that are built into my wire stripper. The reason I'm using cutters here is I realized that I made the junction here a little bit too long.
The Molex pins are kind of, you want to get them the right distance because you want the back pins to crimp, as we said it multiple times, you want the back pins to crimp nicely on the jacketing to reduce the strain, and the front pins to crimp nicely on the conductor. And you don't want the conductor the wire to slip too far into the channel, because that actually might block the male pin trying to get into the female connector. So I guess on the wiki itself, I'll attach, there's a nice like 50-page write-up that Molex did on how to do a proper crimp, which turns out there's a lot of details to it, but I guess in the videos, probably as we've kind of covered this already. So.
Yeah, seriously, if you want to know about how to crimp Molex pins, you can read all you want about it.
Yeah, exactly. Yeah. But yeah, it is important to get a good crimp though, because but once you know how to make a good crimp, it's easy, and it'll save you a lot of pain and trouble later.
Yeah, so let me see, I'm just finishing this one up. And this video may be a little bit long. We'll see. We're probably gonna just keep on recording through this entire process, which is gonna include putting these pins on and testing the whole e-chassis. We have to connect the tether. There's gonna be a lot. So I remember this one's negative, and so this one should be positive, but it's always good to just check, and check again. Because you don't want to get this wrong.
Can't hurt.
Got my continuity tester. It should be positive. It's positive.
We're good.
So here's where it starts getting interesting. So here's my positive pin, and you'll remember we wired the positive and negatives here. Now, of course, again, it's kind of hard to see which is which because they're both purple wires. But here's the positive node, and you can see this is reaching around here and going. By convention, we're always going to do it this way so that the one on the very end is negative, and then one in this pin, the second one, is positive. So now I've got the connector that goes into it. It's going to fit in like that. The second one in is positive. That's this one here. See? So again, with the kind of open flat side facing up, and I'm remembering that this is the positive one. I'm going to click it into place. So just to make sure I'm insane, I'm not insane. If I screwed it up, I'd rather only have to take one Molex pin out. I've now got it locked into place. And there we go. Good continuity. Okay, cool. So that's positive. This must be negative. Now I'm going to put the negative pin in. Bada bing, bada boom. So basically, that's how that goes. Now, this is something that we were talking about earlier. It's kind of this weird aspect of how to do this. If you want to make sure that the motors spin the right direction with the default directionality of the ESCs, there's this way that you can kind of run the motors forward using cockpit once you're running this, and then plug these wires into their respective ESC, and if the motor's running backward from how it should, you can switch any two of the pins, and that will switch the motor direction. The way brushless motors work is that if you have any three wires plugged into any three channels, the motor will spin one direction or the other, and if you want to reverse that direction, just flip any of the two pins, and it'll spin the opposite direction. So it could be those pins, doesn't matter. That's why we're not caring which one is A, B, or C channels, so we just do it that way. If you're doing it that way, it actually may be better, and I should have said this before in the video, it may be better to not plug these into the Molex connector yet, because you're going to want to be able to push these into the pins for the ESCs, see which direction the motor spins, and then if you don't like it, you can switch them, and then after you've figured out the direction you like, then you put them into this Molex connector. And so now that these are already mounted into place, obviously that makes it hard because this has to be plugged in fully in order to provide power to the ESC. The reason I don't think that you really need to do all that, the reason you don't need to obsess about which direction the ESC is going by default, is that in software you can fix it. Our OpenROV cockpit software has a little reverse button. So what might be easier is just to mount these, doesn't matter which direction, and once you open cockpit you can just fix it on your own. So either way you do it, it works. It's just if you're a little obsessive and you don't want to have to press the reverse button in cockpit, that's how you do it. So I have mounted these already into this Molex connector. I've already made sure that this is negative here and this is positive. Now what I'm going to do is put some batteries into our tubes and make sure it's working. First we want to check continuity of both battery packs. So I'm going to do that by putting batteries into one of them and making sure I get 11.1 volts. These Trustfire batteries, these 26650s, nominally have around 3.7 volts each. So 1, 2, 3 of them, 3.7 times 3 is 11.1. So when I push this positive terminal down here, I should be able to measure with my voltmeter, which I'll now put in volt mode, 11.1 volts. And actually these are brand new batteries, so they kind of start off with a slightly higher voltage. I'll bet it'll be closer to about 12. Here we go. I'm putting negative pin in here, positive there. I can hold them in place. And now if you look over here, I'm going to put voltage on. Oh, there we go. So I'm holding my finger there.
I can help that.
All right, you hold that. My cameraman's gonna hold it. I'll hold these here. All right, hold on. I saw 11.1 for a second. What are we doing wrong here?
There it is.
There we go. All right, you have to hold. I wasn't pushing the pins against the connectors very well. So a little over 12 volts. Okay. So remember, these are run in parallel. So I can also plug the batteries in here, but I want to, when I put these batteries in place, I'm only going to connect this one now. I tried this one out and got 12 volts. Now with this one unplugged, I'm going to put the batteries in this pack and see if I can get 12 volts from this one. This makes me sure that I'm getting a supply from both battery packs. If I were only getting a supply from one, the ROV might work, but I'd only have half the current sinking capability, and so the ROV might brown out all the time. So once again, I'm going to take my multimeter probes here, and I wasn't able to make a very good connection last time, but I think this will be better. I'm going to hold it a different way. So now measuring negative, positive, and then put this against here. That worked much better, 12.64 volts.
There you go.
So there's one, 12.64 volts. Here's the other, 12.64 volts. Sweet. We're getting power from both, and that means if I connect both of them, it'll still be 12.64 volts, but coming from two sets of batteries. Cool. So there we go. Now we know that we are ready to plug this into the e-chassis, and the whole system should boot up. I think we'll just pause this video for now, and then we'll get back to that next. What I may do, just to demonstrate for people who do really want to get the polarity right with these, is I'll go backward in time. I'm going to use my little remover tool that I have, and we can show you guys how to make sure that you have the polarity correct for the motors to spin the right way. And again, that's a step you'd want to do before plugging into this Molex connector. So we'll see you in the next video.